a couple of new ideas with this. When we're talking about slope in general, okay, slope can have a couple of different names actually. Sometimes slope can be called rate of change. Okay, you know, my speed increases as I go further, or I spend more money as I, buy more groceries. Those things actually have to do with slope. So sometimes I'm going to go ahead and I'm going to do rate of change, speak of it that way sometimes. Also, a steeper line has greater slope. So in other words, whether it's positive or negative doesn't matter. Whichever one's steeper, whichever one I really wouldn't want to be trying to walk up if it was like a hill. Okay? That'd be part of what I'm thinking about when I'm talking about if a line is steeper. And then the third thing we're going to take a look at today is if you have lines that never cross, that's called being parallel. And the other thing about parallel lines is they have the same slope. Okay? So those are the three main things we're kind of focusing in on today, and how we're going to do things. So, when I start to look at this, again, my rate of change just depends on how far I go up and over. Now, this is kind of a trick question. I'm going to admit it. Okay? So my rate of change is my up or down, my rise, okay, over my, how much I go right or left, my run. If I'm on the same line, which I am here in this one, which has a greater slope, section A or section B, that's kind of a tricky question. Because here, if I look at B and I look at A, they're both on the same line. Because yep, when I go right, it's a positive. If I go left, it's a negative. So when I'm looking at the rate of change for A versus B, the dots may be further apart, but they don't have a greater slope. Okay?
So what if you did the dot between both A and B?
But that would depend on how, and I wish I would have had my lines on here. You would start to notice, depending on how closely together the lines were, if I was counting, like if I had a grid on here, that they actually are going to end up being the same. Because here's how I know that. When you have a straight line, all of your points have to be in that line. So since they're all in the same line, they all have the same slope. So even though to our eye, it may look as though since these are closer and these are further apart, one would have more slope. Exactly. Because that's right. Because if I did A, and that's a good point, because let's say I did A and I went up 4 and over 2, but with B, I went up 2 and over 1. Are those the same? Well, yeah. Because 4 over 2, right. So don't let that fool you. It just kind of reinforces to us that I can use any 2 points on the line, and it'll work for me. Okay? And we're just kind of talking in general here before we get into the specifics over on the back. Because when I start to look at some of these other parts, so lines A, B, and C all have a positive slope, but which one has the greatest or the steepest slope? Which is the one, if you had to walk up it, would you not want to walk up?
I probably wouldn't walk.
Which one of these lines is steepest?
I don't want to walk.
Okay. So that has the greatest slope because it's the steepest one. The least slope is the one that you would actually like to walk because it's going to give you the least resistance. Okay? Right. This one has the least slope because it's the least steep. So if you're ever asked which of these lines is steepest, look for the ones you wouldn't want to walk up. Okay? Wouldn't want to deal with as far as that goes. You could go after it that way. Okay? It's true. All right. Very true. Very true. It would be vertical. So, okay, focus back to math for just a second, even though I like the applications you're putting with it here. So, in the next box, 2 of my lines are positive slope and 2 are negative. A and B I'm being told are positive. Hint, if it goes up to the right, so A goes up to the right. D, not as much, but it still goes up to the right. So those are positive. And then my lines that go down as I go from left to right, yep, would be my negatives. So then to explain our concept up above from number 3, they are. They never touch. That's right. They're parallel. Which means they have the same slope. Now this is just to explain the idea of rate of change. There's nothing we're going to do math-wise here. What we're going to explain is, when you do slope, so for instance here, if I did slope, my rise would be my feet, and my run is my seconds. So what these lines would tell me is how quickly I'm walking, or my rate of change in feet per second. So for instance, if I was just looking at a chart, this person is walking a pretty good pace, you know, they're getting a whole lot of places per second. This is ridiculous. This person's just like speed of light here. I mean, it's going really fast, and this person's basically standing still because time is elapsing and they're not going anywhere.
That I would say would be
0. Yeah, that would be a 0 slope because I'm not going anywhere. Okay? That kind of comes into play when, if we flip over, when I come down here to this one towards the bottom where it says horizontal and vertical graphs, when I go to graph these, I'm going to start with the bottom 4 here. These 2 that say y equals. Whenever you see y equals, just a number. No. Well, yeah, I mean, I'm going to look to where y is 6 on the y-axis here, but then I'm going to draw a horizontal line through there. You're like, but wait a minute, that's going the same way like the x-axis is, and I understand that. But, right, any point that I look at on this line has a y value of 6. My x values may change as I go back and forth, but my y values don't. And then it's the same thing here. Y is -2. A little bit. So we just go to the place on y where that number is and we draw a horizontal line. If x equals, we go on the x-axis to that point. We're going to draw a vertical line. It does, and those are undefined. It says x equals -4. And we haven't started talking yet a whole lot about graphing regular lines, because that's what the y equals 3x is. This is kind of going to be an introduction to that.
What about y equals 3a?
This is exactly where we're heading now. I'm going to introduce something, even though we're not going to start this until probably next week. When I go to graph a line, I'm going to go ahead and start with my dot at the y-intercept, which we'll talk more about at 0. But if my slope is 3/1, what does that mean? Like, what directions would I be going?
Up 3/1.
Okay, I'd be going up 3 and right 1. So I'd go up 3 and right 1, and I'm just going to keep making dots going up 3 and right 1 until I run out of room. Then I just connect the dots.
If you go down 3?
And left 1, I could. I absolutely could. And then there's just some help down at the bottom of this sheet that explains some of the things we talked about. But again, when it comes down to actually getting to it and actually doing it, that's what we're going to do on this other sheet that I've got for you. Right, how are you still being sneaky with this? Okay, so I'm not being sneaky. I'm not good at being sneaky. I'm not. So, at this sheet that we're going to do is our assignment that goes along with. So, okay, find the slope. Reduce the fraction if necessary. Cross out the answers below. So, again, now here they even give me the dots. So again, when I'm doing slope, remember, it's your up or down number that goes on top. So, to get from A to B, I go up 1, 2, 3, 4. So that's the top number of my slope. And I go right 1, 2, 3. And that's the bottom number. And if I can't reduce it anymore, I'm done. And like I said, there's boxes down at the bottom, which in this case, yep, would be IG. We can cross that out. Well, you can try to do something, kind of make bigger here or something, but that's also what the letters are kind of trying to do here and help with it too. A lot of the sheets and stuff have been run off and stuff with me already, so there's not a lot I'm going to be able to do, but we can try to make it a little bigger. But we do have to keep watching. As I'm going from A to B, in. Now here this time I'm going down 1, 2. So it's -6. I went down. And 3, but -6 divided by 3 is -2. So again, don't make life difficult on these. Just kind of work your way through them. So then when you get towards the bottom, down here I'm using my slope formula. And again, you can do it either way. I've got some of you using y2 minus y1 and x2 minus x1. Others of you are using y1 minus y2 and x1 minus x2. That works too. So when I get down and I'm doing these, again, the one thing I have to be careful of is that my y's are on top, 5 minus 3. And in my case, since I started with the second y, let's start with the second x. And then just simplify. 5 minus 3 is 2. 2 minus 8 is -6. And reduce the fraction. And I'm good. So that whole bottom part, that's the way this is going to work. Okay, I just used that formula, a couple of quick things, and I'm good to go. Yeah. So then on the back, okay, find the slope, use labels. This is our rate of change that we were talking about. So I get to the back, and I say, okay, all right, I can pick any two dots I want. I'm just going to use the first two. Now the numbers get a little bit bigger here. So like for instance here, I'm going from, okay, 40 and 80, 20, 60. Actually, I'll write them all in. Unfortunately, we had to make the graph small enough, and it made the numbers kind of hard to read. Yep. So when I go to do this, you're like, okay, so I went up. Now, visually, I went up 1. I understand that. But I'm going from 40 to 80. So I actually went up 40. Because how far away from 40 is 80? 40 away. When I'm going to the side, I'm starting at 5 and going to 10. So I've gone 40 feet between 5 and 10 here, would be 5 minutes. And if I reduce my fraction, I go 8 feet for every 1 minute. And I can do it that way on all of these all the way across. So for instance, yep, 8 feet in 1 minute on the first one. So, okay, the next one. So $15, so I'm going from 15 to 30. And going from 3 books to 6 books is 3 books. 15 divided by 5 would mean $5 for 1 book. So I'm still doing the same thing I did before with slope, except now the numbers get a little bit bigger. Okay, I will make note of that. I will get over there. Okay. So then the middle section is still like what we were doing before. Okay.
Yeah, I understand how to
Yeah, to get from here to here. Yeah, I'm just reducing the fraction. Yep, just reducing the fraction on that first one. Yeah, I was going to say, this. Yeah, you don't want somebody who doesn't understand slope building buildings. That'd be bad. That's not good. Okay, Elliot asked for number 6 on the front. Oh, number 6. All right. No. Someone help me out. Flat line. What's the slope? It's 0 because it's flat. Well, there's another reason besides that it's flat. If I'm doing rise over run, how many did I go up to get from A to B? None. But I went over 1, 2, 3, 4, 5. And 0 divided by 5 would be 0. Yep. I bet you do. And I bet you, especially when you look up the top 8 on there, you're like, oh yeah. Because remember, all we're doing down here in the bottom is using this formula to get my values.